Thanks for coming. Supercharging Kafka processing with Broadway. Certainly, we ran through some challenges, and I wish I'd seen this presentation before we went down this path. So definitely, that's what inspired the talk, was definitely get that in. So I want to just touch briefly here for a second. There's a reason there's a picture up there. This is at Preikestolen in Norway. And the reason I have this up here is, there I was, had to step out onto this little, what looked like a pebble stuck between two mountainsides. It's the scariest thing I've done in my entire life. And public speaking comes very close to that. So join me on my journey as I try to push my comfort zone. I'm a software architect at SalesLoft. I originally grew up in South Africa, where we had to learn to do more with less. And there was a co-founder of a company that worked on workflow products, and we did particularly event-driven architectures. So event stream processing, that's what we were doing. I think as part of this conference, we've all noticed how we're trying to use the different capabilities that are available in the Beam, and in this case, specifically in Elixir itself. So I want to talk about the things there that just for us we found was just so easy to do, which I just wish I'd had all this so many years ago. I've been doing about 20 different Ruby open source projects. The purpose of those projects was really about how do we take Rails and Ruby and take it into the software as a service space. Enterprise customers, so large implementations, and that's what those were put together for. And again, coming to Elixir, I just loved the do more with less. It really addresses and it hits home for me. So let's jump straight in. So what was the problem we were trying to solve? So we needed to do essentially a domain-specific rules engine. You can see there we have a Rails monolith from which we're getting a lot of messages coming to Kafka. We had Elixir services. We also have a lot of events coming in from outside parties. So we have partners that give us information. And being in the sales engagement space, for example, if a customer goes and views or a prospect goes to a website, views a video, we want to know that that's what happened. And those events are coming in real time as that occurs. And we want to take action based on that. So there's, in SalesLoft, this is a large infrastructure. There's a big pipe of data coming through in that Kafka infrastructure. It's an existing infrastructure, so they're already partitioned by what they call tenant ID. So being software as a service, you have many tenants, and we want to make sure, so it's all coming through partitioned by that tenant ID, and then I'll get into the reasons later for that partitioning. And then on the outside, when we go through the rules engine now that we're building, what it needs to do? It has to perform certain actions, and those actions are HTTP calls outbound. And this is really high volume infrastructure. So this Kafka pipe we're looking at, it's like drinking from a fire hose. It really is. For the amount of data we need to do in the processing, it's a significant amount of data coming through. So what is Apache Kafka? I'm sure I maybe see some hands. How many of you are running Apache Kafka? I guess that's the title and the subject, so I guess most of you have been running it. I've been using Kafka not only at SalesLoft, at prior companies, and I always did the training, trying to understand what it is. But I think at the end of the day, the simplest way to describe it, well, I guess let's start with the write-up. It's a high volume, high throughput, distributed event streaming process, event streaming platform. So, under the covers, the way I look at it, I look at it more like a database transaction log. So if we have a look here at the picture at the bottom, if you have a single partition topic, you can think of it as you have a bucket, you have all the little messages coming in, they're immutable, meaning once a message comes in, you cannot change it. And the benefit with a transaction log is once that particular little bucket of data gets full, you just jump to the next one. So here we can see we come in, we fill it up, go to the next one, we fill it up. The nice benefit with that is, obviously all your messages are stored in order that you received them. And when we want to clean up the older ones, we just literally just drop those old files. So database transaction logs have been around a long time with databases already. So it's a great way for doing it. It's highly performant because you're just reading the log itself. So that's really the way I look at Kafka under the covers for a single partition. So one of the biggest challenges we run into is how to scale the consumers with Apache Kafka. If we have a look on the left-hand side, this is we have a topic that has 3 partitions. So, when you create a topic, you tell it how many partitions to put in there. Most developers say, I don't know, give it 5 partitions. We don't really know why we give it that many partitions. But we created that, and this is where we start. So in this scenario, let's say we just created 3 partitions. So one partition goes to one consumer. So the first 3 consumers in this picture are busy. So that's great. But we started at 5 consumers. What are the other 2 doing? They're essentially sitting there waiting for work. And we ran into this problem with several of our implementations. So what do we do? I'll get into that, I think. So there's another problem you run into. Even if you're going to create, say, 1,000 partitions, you run into the unbalanced partition problem. Now remember earlier, we partition based on tenant ID. So what happens is that if you have one of your tenants gets really busy, maybe they uploaded a large amount of data, and we've got suddenly a lot of events flowing for that one team or partition, one tenant, you can see suddenly there's a lot of traffic coming in on just one partition. So all the other consumers are pretty much idle at this point. So you're sequentially processing just one partition by one of the consumers. So what a common description, the phrase I heard it sold off thrown around a lot is the noisy neighbor. Again, so it's not just if it's just one team or one tenant that's creating a lot of traffic, they're really impacting themselves. But what can happen is because we're using a partition key, you could have multiple tenants on the same partition. So at the back of this queue, we could have someone that submits one event, they're now waiting for that customer in front of them before their data gets processed. So what Kafka does recommend to address that is to do random partitioning. But then obviously if you do random partitioning, you can't associate the ordering by tenant doesn't happen. So for example, we're publishing the create events and then we publish updates. It's possible that you get a update before you get the create coming through. So that's why they want to do the partitioning by tenant. So the partition count. I read a lot of blogs on this. New Relic have some really good ones. They talk about because they can go to thousands of partitions with Kafka. So if you do want to look at increase in the number of partition counts, it's a great place. A lot of really good reads, again, on the New Relic blogs for Kafka. The challenge here is you need to assign just the right number of partitions. And again, so when you are the one that's creating the partitions, when you create the topic, you've got to say how many partitions you want. If you do too few, we limit the scalability. On the other hand, if you get really high and say, oh, just create me 10,000 partitions, well, that can create some performance challenges. So we have to get it just right. You can increase partitions. I don't know, have many of you tried to create, or have you increased partition sizes in production for topics? So yeah, it can be done, it's just that it's not easy. I know at SalesLoft they haven't increased ours, but they didn't want to go they're basically sitting around 64 partitions. That's where we're at right now. So it's a little tough to try and get that increased. But so it's difficult to do it. But there's no magic formula, and at the end of the day, even reading the New Relic blogs, they're just saying you read it, you try it, and then you tune it appropriately. So the moral story I'm trying to get to is that the partition count is something that's complex to set up and get running. So here we go. Here's the big question: the scalability. How do we scale our consumers without, having to constantly fight with this partition count? Or is there another solution that Elixir offers? And that's really the beauty of the story. Elixir has lots of concurrency models. So there's a list of them. And I think everyone at the conference heard all about Flame. We have yet another one. So there's lots of different options available. And I think that was the challenge, the task we were faced with is, this is the problem we're trying to solve. How do we know which one to pick and what are we supposed to do? So let's just look at them very, very briefly. I'm sure most of you are familiar with task. Very simple, task.start creates you a nice little process. You can run something asynchronously. You can even run the task supervisor. So if you want many of them, you can also limit how many processes. So for example, if you're reading a file and you just want to say, give me 100 processes that go off and process that particular file that you're processing, you can limit it with that. And you can do a supervisor, restarts, things like that. So it's pretty straightforward. That's task.start. And obviously we now have flame.call to do that remotely. So if you want to call in a remote service, another option. Gen service, I know people are new to Elixir. It sounds scary. It's just a generic server. Runs as an agent. It's really designed for complex tasks. So somebody has to do something more than just something simple. You want to maintain state, and generally it's something that's long running. So we did, in our first implementation, we just wrote a gen server, put in a Kafka consumer in there, and it processed. It would fetch one message at a time, process it, and then go ahead and fetch the next message. So that worked. We had one gen server. We deployed it to production, got our proof of concept up and running. We needed to consume more partitions or more parallel, or just start more containers. So it achieved the proof of concept. It worked. Our next step was going to be using a partition supervisor to see if we could create more gen server, more instances. So that was right at the point where we're at. So then I've been to several talks, other conferences, and Jose's done a great job of talking about something called GenStage. Some very, very technical presentations talking about it. This really, I guess, game-changing type of technology on top of Elixir. So just a very quick summary. So essentially, and again, I'm sure most people have seen Jose's talks, but essentially you have a producer at the beginning of your pipeline that passes it on to a consumer producer. There's going to be a consumer producer and then a consumer at the end. The idea is you can basically push messages down this pipeline and it'll process it for you. So we could have Kafka at the beginning producing and then just push the data as it goes through. Now, the key difference, and this is, I think, what is the key game changer for me. Again, I've worked with event-driven architectures, and essentially there what we do is we use queues between each stage. So in this scenario, yeah, if you have the producer producing like crazy, and then you have another consumer producer below, we would generally have a queue in between each of those, an external queue resource. But with GenStage now, you can do this all in process. So in your same process now, you can push. Well, if we were just pushing, we can push through as fast as we could. But with back pressure now, it changes the game in the sense that a consumer, so if we start at the right-hand side, the consumer will ask the consumer producer below for, say, in this scenario, for 100 messages. This one will pass it down to the producer. So then the producer, let's say it's the Kafka one, will send it up to, at most, 100 messages down the data stream. So this way, in memory, we don't run out of memory because we're not pushing all the Kafka messages through as we receive them. The consumer will let us know what it needs. And then just one little quick bit of information on the consumer side. And this is something really cool that's been implemented at GenStage. When it's, say, in this scenario, let's say it's 100 that we've asked for. When it's finished processing the first 50, then what it'll do is it'll ask for 50 more and then continue processing. So those the request for 50 will go down the pipeline, and then the idea is that by the time it gets back for the next 50, it's finished all 100 at that point, so it can continue process. So every step will be busy. It's not a case of I'll do 100 in the consumer, go all the way back and ask for the next 100 and wait for that to come. So I'm just showing this is the under the covers. This is the complicated stuff that goes on underneath for you, but it is just really awesome the way now. As you saw earlier, we had the pipeline. Now I can say how many I want of each to be created, and GenStage does that for you. So you can automatically decide, now I want so many of this consumer producer, so many of those, and so many of those, so you can get the concurrency immediately in your pipeline. So it's all great parallel processing. So I don't know, again, show of hands, how many have done Flow? Excellent. Well, Flow is actually really powerful and very easy to use. Highly recommend it. If you're just going to, somebody need to process a large file, a large amount of data in a database, you can just grab Flow. I couldn't find a nice cool logo, so I stuck some source code up there. I don't normally want to show the source code in this, but it just shows you how easy it is to use. It's based on the existing APIs. Jose has done an entire presentation just on Flow, so if you want to see that in more detail. But at the end of the day, it's very easy to use. You've seen what GenStage is underneath the covers that Jose has created so that you can just use this and not have to worry about all that complexity. But under the covers, that entire GenStage pipeline is done for you with this. And this is a great way if you want to do MapReduce type capabilities, you need to do any filtering, grouping, sorting, and you can also partition. So if you wanted to partition by, I don't know, the tenant ID. So you're reading a large file, you want to make sure that you want to partition up the processing by tenant, it'll do that for you. And there's some other great features, windowing, triggers, those are actually really cool features. So if you do want to look at that, this is great for just grabbing a file, processing it, or just processing a large amount of data from the database. And again, it has back pressure, but that's GenStage. GenStage is doing that for you. So all under the covers. So another one is Broadway. So if we want to do event stream processing, Broadway is a perfect fit. Again, same, very similar phrases, high volume, high throughput, event stream processing. So it and Kafka seem to be a good match. Same thing, multi-stage processing pipeline on top of GenStage. And same with the back pressure. And then some other cool features like rate limiting. So very often if you have one of your stages, you want to make sure you don't overload downstream systems with distributed denial of service against yourself. You can limit the number of those consumers. And then something I'll get into a little later, some of the batching capabilities too. So that's the Broadway very quickly. And of course, Urban. So I've seen some presentations on that. So one of the reasons we use Kafka is because we have such a high volume of data coming in that we want to be able to stream that data and use it downstream. So one of the challenges that with Urban, we're going to store it in Postgres. So we don't want to go from Kafka into Postgres and then have it processed by clients. So Urban is better suited for larger jobs, higher granularity, so forth. So we looked at that. So it wasn't ideal to take our entire stream of data from Kafka, this big pipe, and shove it all into Postgres. So as you can see, the concurrency model, we decided to go with Broadway out of all those options. So just a quick overview, you can see where that fits in. So Broadway to the rescue. So if you remember, one of the challenges we had earlier is you only had one consumer per partition. So you can imagine if we had a single partition topic, we can plug in the existing Kafka producer and put as many consumers as we want to. In this scenario, I'm saying let's say 1,024 consumers. So with one partition, you can go ahead and parallelize immediately. So that's what Broadway does for you. That's a phenomenal, just make it parallel and I'm done. Try to do that we have a lot of Ruby infrastructure that it can't do that. It can't just suddenly go ahead and do parallel processing like this. So again, Broadway just makes it easy for you. Multiple partitions, even in the scenario where we have three topics coming in, three partitions on the same topic rather, with over, in this case, 1,000 consumers, you can go ahead and do that straight away. All of those consumers will be busy processing all messages coming off of that topic. And again, we go back to the unbalanced partition problem. We just have one partition that's backlogged with a lot of messages. How do we make sure we process all of those messages timelessly? How do we deal with the noisy neighbor problem? How do we can get that all processed immediately by having all of our consumers work on all the data that's coming in. So again, Broadway solves that problem for you. So you don't have to worry about how many partitions do I have to create. How do I deal with unbalanced partitions? It can do that for you. So if we look back at our rules engine that we were trying to build earlier. Again, so now, before we did Broadway, we went ahead and did the Gen server, as mentioned earlier, so just a Gen server implementation, and we were going to move on to doing a partition supervisor, so that way we would have one Docker container running with a single Gen server processing the messages coming off of Kafka. So the very first iteration of putting Broadway in, all we did was change our code, we ripped out the consumer we went and wrote ourselves for Kafka, and just dropped in the Broadway consumer, and away we went. Now all of a sudden we have all of these we can have as many consumers going as we want to, processing those messages coming off of Kafka. So it was a very simple change, very straight, and that was just the first iteration. But immediately it gives you that power. So again, we using all the capabilities of, so you've got Broadway, you have GenStage underneath that, the whole processes underneath that within the Beam platform. So it's very quick and easy to fire up your consumers. And now you're also getting the beauty of all the supervisors that are built into GenStage. And you don't have to deal with any of that yourself. So then we went through and did another iteration. So the first iteration was just parallelize what we have. The next iteration, and it really wasn't that hard to do. This is the concept of adding batches. So if we look in the top, we have a rules consumer that handles all the messages coming in that are related to we want to process to the rules engine. So even though we're reading one topic, we want to be able to take the different messages and send them to different pipelines. You can think of it as that. So this one's the rules. The one below it is every time a tenant gets created or updated, we want to know about that, so we can, for example, create new default rules for that tenant. So By doing these parallel pipelines, the behavior is separated. So each pipeline has its own behavior. You don't have to worry about having to have one consumer that knows what all the different types of messages are. So that's the first thing. The other thing is, by doing batching, you can also process multiple messages at one time. So if we look at this one here, for the tasks coming in. So we would get together a whole bunch of task messages. So let's say you decided to configure it to up to 100 tasks. The traditional approach was, when we were doing it earlier, we were going through and say, okay, for every task, we need to delete all our reference data, which was in a reference table. So we would do a delete for every single one of those tasks that came through. Now, because you're using batching, you can say, give me 100 messages. We would go through, collect 100 IDs, and just say, delete 100. With a single query, you can tell it delete 100 rows in one go. So you can get scales of efficiency by calling one database operation as opposed to 1,000 or more database operations. It's, one at a time. So it's just, so batching, and again, it's much easier to implement than one would think. So it's really, anyway, it's phenomenal. Basically, you can categorize, you can get groups together, and then have separate pipelines for all the different kinds of data off of the same topic. So again, if we look at the on the rules engine solution, we have the multi-stage going now. So not only do we want to have one consumer, if you look in this one, we basically have a single consumer. I mean, they're all different consumers off of the same batch, but it's just one step. It's the actual rules engine. So what we want to do in this scenario is, not only do you have the rules engine, but the rules engine can then perform actions downstream. So instead of doing the rule and the action as a single entity, you can break it apart and say, let me run the rule and then have the rule pass on the actions that need to be performed. Call this service, do this call, things like that. So you can break it up into multiple stages. And then additionally, by doing the multiple stages, it comes back to rate limiting. One of the things we're doing is calling downstream HTTP services. We can't call too many of them too quickly because we could either do a denial of service, or maybe they have a rate limiter that we don't want to exceed. So you can then do rate limiting on your various downstream consumers. So the rules can execute as fast as we want, but let's put a limit on the number of on the consumers that are being executed. So what would we do differently? So if we have a look, one of the key things is we would have gone straight to Broadway immediately. Instead of going and doing what we did, I'd stuck a little bit of code in here. I said I was trying not to do too much code. But if you look at this diagram, or the source code, under the start link, this is all just really configuration. There's no real code in here. This is just telling it, go ahead and use the Kafka producer. We are telling it some configuration of what the Kafka broker is and so forth. Your consumer group ID, we just put that in there. And then the list of topics. So if you want to consume from multiple topics, I really didn't talk about that much earlier, but we don't have to just consume from a single topic. We can, as new topics come along, we can just add it to this list. And then all of a sudden, our processor now is handling multiple topics and is parallelizing against all of the consumers that you have available. So some topics could be very busy, some could be quiet. It'll automatically handle all that for you. So you can set the concurrency as to how many you want, just straight in there. So again, this is all just configuration. And then I just did the very simple implementation, the handle message. This is a screenshot directly off of the Broadway Kafka producer documentation site. And there it is. So that's how hard it is to create a consumer using Broadway. So you can very easily do this. The other benefits, so for example, I know if you're running, say, Amazon SQS. So instead of running SQS locally, you could run something like Apache Kafka or RabbitMQ on your local development machine. And just with a configuration change, switch over to, say, Amazon SQS, even Google Pub Sub in your testing environments in production. So you can use the same piece of code regardless of which data source you're reading from. So that's, again, another reason I say just go straight to it. Don't even bother trying to write your own client, reading from Kafka, what have you. Just go straight to Broadway. That's the piece of code. So some of the challenges we ran into. So one of the things was we had some issues with the acknowledgement. So when we have a pipeline, the idea is that as you go through, the actual acknowledgement back to Kafka only occurs after the consumer has finished processing it. So that way we get resiliency. So it doesn't acknowledge. Now we ran into some problems where if we didn't have enough of basically the Broadway Kafka producer at the beginning to match the number of partitions. Sometimes the acts weren't going back, the acknowledgements. So we wanted at least as many consumers as we have partitions. So that's the only, I guess, thing we bumped up against. So do recommend having at least as many consumers as what you have partitions. And I think just general Kafka best practices. So for us, thankfully, a lot of this was already in place when we came along. And so we could just plug right into it, put a rules engine in there, and immediately it was all JSON data. Every event had a name, obviously at the type of the event. So we have I guess a person could be created, updated. So we'd know what type of object it is, and then obviously the event data. One of the key things for Kafka in general is they do recommend using some form of idempotency key. Because as you know, with Kafka, it's an at least once delivery. So we don't ever want to perform an action on a downstream system twice. It's very important we don't do that, because often we're creating an action which is to create a human, assigning a task to a human, like a to-do entry. It's like a task, an action needs to be performed. We can't create that same thing twice. We don't want them to do the same thing. So it's very important you check the idempotency key. If you can have it generated when the message is generated, follow it all the way downstream, and then make sure that you haven't already processed it. So just one of those key things when working with Kafka. It's an at least once delivery. So again, creating new topics. I went through this earlier. There's lots of blogs again on it, and trying to get the right partition count. But the beauty is you've got Broadway. You don't need to worry about that anymore. That's now the teams that are working in the other languages' problem to deal with. So that for me was a big win, just straight out of the box. So if we have a look at some of the other Broadway features, there's again the back pressure. That's the big game changer. I think that's what I saw when Jose presented I think it was in 2016. He did the presentation also in Orlando with Flow, and he spoke about how that back pressure works. The ability that you can bring is not just pushing and overwhelming, it can push back and say, only give me what I can process now. And that way we can do it all in memory. There's no worrying about having each consumer write off to another queue and then process that off for another process. It's all done in memory at extremely high performance. Again, so the automatic acknowledgement end of the pipeline, they do that for you. When the consumer's finished, it'll go through and acknowledge back at the Kafka producer. You don't have to worry about any of that. The batching, as you saw, you can batch it up. You can create categories. You can get many messages at once, so that you can optimize your SQL queries or updates. It has built-in fault tolerance. It's built on top of GenStage. GenStage automatically has all the supervisors to make sure that nothing fails, restarts. That's all taken care of for you. A graceful shutdown. So in other words, if you have your pipeline running and you decide that you're going to do a rolling deploy, well, we're going to make sure that whatever's in that pipeline doesn't get lost. So it stops producing and waits until the consumer is finished before it starts shutting everything down. So all the little things you don't think about that Jose and his team has already taken care of for us. Metrics, all built in. I think you saw a lot of the telemetry presentations. Some of the stuff, the colon telemetry, that's already publishing all those metrics. You can have a look in there. Custom failure handling, I didn't go into that, but there's some really awesome ways of categorizing the different types of errors and what to do. The documentation is great on that, and it's just we found it a great way to handle errors and to report on those errors and to categorize them too. There's also something we haven't touched on, ordering and partitioning, but it's great to know Broadway has those capabilities if we need them. So you can tell how you want the message ordered, and partitioning, again, you could partition by tenant ID if you needed to. All, again, part of GenStage. And then rate limiting. So again, important you don't deny the service yourself. And then also it has a live view dashboard. So if you wanted to see what's going on, there you go. You can plug this into your Phoenix Live dashboard and get a view real time of all the different services that are running, all the different consumer producer consumers, and your consumers, and see if you have any bottlenecks and how you need to tune that. It's a really awesome way of being able to look behind the curtain to see what's going on. So, any questions? I'll try to leave time for questions.